Hey everybody, lovely to see you once again that you're joining us for the Encode Wormhole Educate series. This is session number 3, and today we're joined by a very special speaker, Chase Moran from xLabs, who will be telling us something about messaging and relayers. Chase is getting ready to join the stage right now, but in the meanwhile, you know the drill. If you have any questions, feel free to pop them in the chat or in the questions tab, and then Chase will get to them in the last 10 or 15 minutes of the event. Hey Chase, welcome to the stage.
Hey, how's it going, everybody?
Yeah, looks like everybody is loving the event so far, and everybody's here as well. Love to see him as always. So yeah, feel free to share your screen, and the floor is then yours. Thank you.
All right, so a little context. My name is Chase. I've been working on Wormhole for a little over 3 years now, working as a core contributor. I've been on it since before the launch of version 2 and worked on a lot of the sort of major parts of the ecosystem, did a lot of work in Portal, also worked on the standard relaying protocol, which we'll be going over in some depth today. And yeah, now I'm at xLabs, and let's dive into it. Yeah, so I think the objective for today is just to sort of go over the basics of messaging, relayers, sort of the key primitives that make Wormhole work, and just kind of understand a bit of the terminology and also some of like the key challenges and some of the things that you'd want to know going into integrating with Wormhole, or sort of like understanding what the platform is capable of doing. So basically the whole overview is like, what does it take to make Wormhole work? So Wormhole has been in active development for close to 4 years now. So there's quite a few moving parts. It also is a very, very big ecosystem at this point. So that it has a lot of features, it spans a lot of ecosystems, and it's designed to suit a variety of use cases. It's also designed to be very modular. So you can kind of take the pieces that make sense for the application you're trying to build, and not be sort of bogged down by features that don't make sense for you or aren't integral to the application that you're trying to build. So basically the agenda for this talk is going to be, first, we'll go some history and some context of just sort of how we got to the world we're in today. What was sort of the impetus for starting Wormhole? What was the world like 4 years ago that sort of made this technical stack go the way that it has, and just sort of the greater context. Then we'll go over the sort of 2 pillars of smart contract interoperability, which are attestations and relaying. We'll also get into the standard relaying protocol on Wormhole, which is also called SR. So I'll be saying SR a lot today. And we'll walk through a hello world example of just sort of like the most basic messaging example you can do on Wormhole in like 20 lines of code, not even. And then, yeah, we'll get into some additional features, some additional options you could do, additional modules you'd want to plug in, as well as some use cases, some other product offerings that Wormhole has, all of those sort of goodies. All right, so what is the concept behind Wormhole? Basically, smart contract interoperability. A brief history of Wormhole is that the project was originally started by a firm called Certus One back in 2020, and it was actually a Solana hackathon project. So I believe, they basically built a very sort of standard token bridge, specifically designed to go between Solana and Ethereum. And these were, pretty early days in the Solana ecosystem as well. It was a very sort of simple token bridge. And then I believe the Solana Foundation followed it up with a grant or something of the sort. But the sort of key change that happened is from 2021 onwards, really. In 2021, basically we we had the idea to abstract out the token bridge. So the V1 token bridge was very much just designed to do a compatibility standard between EVM ERC20 tokens and SPL tokens on Solana. But at the end of the day, blockchains are kind of just computing platforms, and tokens are just another form of data. So it's actually not a tremendously big leap to go from a secure token bridge to a secure general message passing solution. And the key idea there was that heterogeneous ecosystems were starting to become very important, and Wormhole had a leg up in being sort of immediately established in the Solana ecosystem, as well as immediately prioritizing some Cosmos ecosystems, quickly expanded to Algorand, and also the Move ecosystems. So the sort of key idea here was take the token bridge, abstract it out to be a general message passing solution, specifically designed for Pyth, which is of course also on Solana, and heterogeneous ecosystem support rather than just sort of EVM as would be the standard at the time. So there's a few key points here. Like if you think about the difference of like a token bridge is obviously like a point A to point B style of problem, right? Like there's always a source transaction. You take some tokens, some data payload, whatever, and there's always a target transaction. It's just like get the thing from point A to B. On the flip side, Pyth has a tremendously different architecture, and it was a use case that we wanted to support from the absolute beginning, right? So what Pyth basically does is producing state updates every 400, 600 milliseconds on Solana, and basically dumps its entire feed into Wormhole. So Wormhole is just cranking out these attestations of Pyth prices, which are then lazily relayed. So despite the fact that that Pyth produces like 3 million messages a day or something, I don't even know how many it is nowadays. A lot of those never actually make it onto a chain. They're sort of just like available, and then a newer one comes out, and a newer one comes out, and a newer one comes out, and they're only delivered if there's a need for them to be delivered. So there's always like a super fresh price available, but there's not necessarily anyone who needs to consume it, and why spend the transaction fees if no one's going to use it? So this like lazy relaying strategy was very important. And then also the heterogeneous ecosystems are an important consideration as well, because the just actual code you have to write in order to interact with those chains can be wildly different. So those are primary considerations. And sort of from that basis, we've simply built on top of it, right? So sort of once you have these core security primitives, core messaging primitives, once you have message passing, you can kind of build anything you can fit in a payload on top of it. So nowadays we have SR, standard relaying, which is sort of a really good zero infrastructure solution for getting up and started really fast on Wormhole for a majority of common use cases. NTT is one of the latest things which has come out, which is a way to just very quickly, in basically minutes, deploy a contract for ERC20 tokens and also SPL. And I'm sure it'll be expanding to more ecosystems very soon. Just sort of like deploy that across a bunch of ecosystems. Under the hood, NTT leverages SR by default. So it's sort of all dog-fooded together in that way. There's also a lot of key composition points of using, like, as I said, not only SR, not only NTT, not only the token bridge, but sort of like stacking these things, like having all of the modules work together so you can just sort of like stack them on top of each other, and the ecosystem becomes more powerful over time as you sort of have more of those Lego blocks to work with, let's say. Okay, so yeah, today we're on 30 plus blockchains. I don't even know, it feels like a new one gets added every single day, and there's 7 ecosystems, which I don't think anyone else is even close to that at this point. Okay, so if we're gonna sort of break it down to interoperability at the smart contract level, which is interesting because it's not the only type of interoperability. IBC is a good example of a different model, which is sort of like more built into the consensus of the blockchain and has like a fundamentally different model. Also, if you sort of like take the L2 model as being a form of like interoperability or something of the sort, that's also quite different. So this is smart contract based interoperability. So treating the blockchains as basically arbitrary computing platforms where you can execute in smart contracts and do message passing between multiple smart contracts. So kind of the message passing effectively feels like networking for blockchains or networking for smart contracts. And there's really two pillars to this. You have the attestations and you have the relaying. So attestations are any verifiable message that confirms an event happened on a given blockchain, or just a state attestation. It says the state on this blockchain at this time was this thing. So it's simply just a message which is signed by an authority, or it doesn't have to be signed, it just needs to be verifiable. ZK attestations are, kind of one of the next frontiers that we'll be seeing roll out over the next couple of years. There's sort of multiple ways to get this done, but the important part is that it's verifiable. And then relaying, right? So you sort of like have the state attestation that says, here's a thing that's true. And then the relayer, the relaying side of the house is responsible for actually taking an action as a result of that. So, based on that there was a message emitted over here, we have to go produce this state update on this chain over here, according to the protocol standards or whatever it might be. So these are definitely like the two most fundamental primitives and components in the interoperability stack. So let's kind of dive into them one by one. So the most critical component for attestations and the security of Wormhole as sort of its entirety is the Guardian network. So the Guardian network has a few different things going on internal to it. We don't need to get into them like super in depth, but for the most part, when we talk about the Guardian, we really mean the Guardian base node. And this is what the Guardians do. They all run a Guardian base node. And basically what this is responsible for doing is monitoring the core layer on every blockchain in the Wormhole ecosystem. So this is quite a serious undertaking. So that's kind of why the Guardians are the entities that they are. You really need to be a very serious validator company in order to run one of these. And then also internal to the Guardian network is Wormhole Gateway. So Wormhole Gateway is a Cosmos blockchain. It's like an entire Cosmos level, layer one. It has a custom consensus mechanism, and it's built to basically handle like internal infrastructure to the Guardians where they need shared state. It's also capable of processing governance and some things like that. But its two primary things is just to be the point of shared state between the Guardians so that they can, where there needs to be consensus among the Guardian network for things other than producing VAAs, basically it gets stored there. And it's also the interface into Cosmos. So in Cosmos, like the standard is kind of to use IBC. And so you have the capability of going through Gateway to then hop on IBC and go interact with the Cosmos ecosystem as well. And then it's also worth mentioning that there are quite a few internal protocols to the Guardian network. So there's an entire governance mechanism internal into Wormhole right now, which is quite elaborate and is being expanded upon as well. There's also cross-chain queries, which we'll talk about a little bit more later. There's governor. So one of the key things about the Guardians is they effectively have the entire state of like Web3 available to them because they're running all of the blockchains. And so they all have a global picture of of Web3. And what that allows them to do is just execute checks you couldn't do on a single blockchain. So for example, the governor is context aware of how much like notional value of a token has been in flight in like a 24-hour rolling window. Similarly, the accountant is fully aware of like the total circulating supply and can enforce invariance like that. You know, you don't have like a logically impossible transfer where like a blockchain transfers out more tokens than it ever had in the first place. And then, you know, there's other defense and in-depth strategies going on here, but there's quite a few things going on internal to the Guardian network just on top of producing VAAs. Okay, so the Guardians, real fast, why are they necessary? So the Guardians produce attestations. And the key challenge here is that they really need to be experts in blockchain finality because blockchain consensus and finality is way messier than you might sort of want to think it is. And it's a really critical security point that just like the Guardians be experts in validating finality of blockchains and sort of all of the weird edge cases that can occur surrounding that. A question that everyone always asks is why 19? It does seem like a pretty arbitrary number. It is a pragmatic engineering trade-off. It's not a magic number. Like you know, it could have been 20, it could have been 10, could have been whatever. It can expand in the future, but 19 is a number that's pretty good as far as decentralization goes, and it's also, especially back in like 2020, about how many really good validator companies there are. So you have to really be a robust validator company in order to run one of these things. And if you were to say have 200 Guardians or something, it would be one, a lot more expensive, and two, you'd probably be really scraping the bottom of the barrel in terms of just how many teams you could find to run these things. And the VAAs have also been designed with a level of future compatibility in mind. So the actual like signing methodology or mechanism by which it's verified is like fully replaceable. So it should be forward extensible to ZK in the future or different signing strategies or anything of the sort. It's treated as a black box. Right. So a couple of just fast things that go wrong with the Guardian network, right? And sort of like here's the primary things you have to be aware of is the Guardians run full nodes. So this really helps avoid certain edge cases that can be a strong concern here. So one of the things that could happen is that you know, a blockchain can just silently hard fork. Not naming any names, but it happens. And if you were to, you know, not be validating the sort of full state of the network, or just sort of like consuming blocks without checking consensus, you could just sort of like silently process a really huge state change as a result of that. But there's also sort of the standard rollback, standard orphaning, network partitioning. The monitoring also becomes really important from just like a liveness perspective. So you kind of want people who are validating, not doing double work here. They're already validating these blockchains and they have a lot of monitoring. They're fully aware of like the responsibilities as a validator, and running a Guardian is sort of just almost for free if you do it on top of all of that. There's a couple other features. You can send instant messages on Wormhole, so they won't wait for finality. This is really useful for cases where you're just sort of like sending a live state update, and if you miss it, you just pick up the next one or something. CCQ is also an ability to send a message, or rather produce a state attestation without having to interact with the blockchain. So this is very useful in the case of like, you just want to read like a wallet balance off of Ethereum or something, and you wouldn't want to have to like pay $5 or $10 to go produce that attestation on Ethereum, when you could just sort of like go to the Guardians and be like, you know, please do this for, please save me the money. And then also this, as I said before, the global shared state Wormhole gateway is another key advantage that sort of wasn't possible prior to the Guardian network to implement such checks. So VAAs are the sort of like key backbone messaging piece of the interoperability stack. So this is the data model, the sort of like fundamental thing you get when you're sending around messages. And I think like just looking at the fields kind of like gives you an idea of like, okay, you like produce these things and then you consume them. So like when you emit a VAA, there's a version on it. There's a timestamp, which is just the timestamp of the block when you emit the thing. A nonce is just like a integrator field. You can use it for whatever. It's just basically for deduplication if you want. There's an emitter chain, there's an emitter chain and the emitter address. And so the emitter address would be like the integrating contract. And you'll see that it's a bytes 32 because this is in Wormhole address format, because obviously different ecosystems have different address formats. So Wormhole has a compatibility format for that. The sequence number just makes every message unique at finality because you just get a monotonically increasing sequence number. Consistency level is an enum, where you can basically specify instant or at finality, where the guardians will wait until finality so that there's no chance of a rollback. And then payload is the actual sort of content, like it is the arbitrary message. It's a byte array. You can put whatever you want in it, so long as, if you can fit it in a blockchain transaction, you can send it on Wormhole, basically. So the sort of key functions that you use here is, if you go look at the Wormhole core contract, there's quite a few functions, but like these two are the real guys. Like if you're only gonna think about two of them, these are the ones. So publish message is the way that you send a message. So in the Wormhole ecosystem, every single blockchain has a core contract. And so the core contract is capable of emitting a message by calling publish message, or if you show up with an attestation, which you can get from after the message is created, you can get this either live off the Guardian network because all of the Guardians have all of the VAAs available. It's also like indexed for convenience in Wormhole scan, and there's like a few other ways to get them. But basically, you publish a message, the Guardian network produces it, someone picks it up off the Guardian network, and then you can bring it to any blockchain, any other blockchain. Like any core contract is able to verify any other core contract's messages. And you do that by calling verify VM, right? So you just basically show up with the VAA, call verify VM, and verify VM, which is just VM is verifiable message, returns, a Boolean. Like, is this a forged message or is it real? And those are, at the end of the day, really the two most important calls. Every single Wormhole integration either calls these directly or calls like some contract that calls it on your behalf. So you can kind of get up the stack, but at the bottom, everybody's calling these. Okay, so that brings us to relaying. So where the core contract is sort of responsible for this, like produce the thing, verify the thing, you still kind of need like the whole rest of interoperability, right? Which is actually making contracts, calling them, executing arbitrary business logic. And relayers are really important to that effort. So you should think of the attestations as sort of being like the core security fundamental. Like they are sort of the thing that makes sure that the messages remain intact and like can't be spoofed, can't be forged. Whereas relayers are the delivery service. So the way that I like to think about this is like when you like purchase something off of Amazon or whatever, you don't really care if the package gets delivered via UPS or FedEx or whatever, as long as the package is still intact. So relayers are really like a delivery service, and so long as the package makes its way to you unharmed, who cares? So this decoupling is actually fairly novel. Like a lot of other sort of interop solutions and architectures don't have this permissionless relay aspect. And because of this, it allows really diverse relay strategies to be built on Wormhole. Like, for example, bridging is this like point A to B, and that's obviously very accomplishable on Wormhole and kind of like the standard use case everyone thinks about. However, things as wild as Pith are also perfectly accomplishable. And then we also have now a standard relaying protocol, which allows you to sort of like, for most of these common use cases like bridging, sort of like the things you immediately think of, just get that done in like, 10 lines of code or whatever. And one of the main things here is that because the relaying strategies are totally divorced from the security, you're able to, one, really increase composability, and we'll show a couple of examples of how you can do that later. But it also allows like different relaying incentives. So, you can have a thing that's, you can have sort of like prepay, you can have bounties or things like that. But you can like really design a whole bunch of different protocols and, bake in application logic and really optimize them for your exact use case and design custom protocols. So now that we've kind of gone over this, I just find this diagram to be like a really good like A, B, C of the thing, because it pretty much has like all the pieces, all the terminology, and just sort of like shows the A to B. So you always start off in a source contract, call into the Wormhole core contract. Specifically, you're going to call published messages. The Guardian network will then pick those up, produce a VAA. That will make its way into a relayer via several methodologies, pick your poison. And then that makes it over into the smart contract runtime. And for most integrators who would be using SR or something of the sort, starting out, you could then, maybe later go to something more advanced and just roll something custom to like optimize for your exact use case. But from the perspective of an integrator using standard relaying, at least, you really only end up kind of like making one call over here and making one call over here. This Guardian network, the relayer, it's important for, it's important to understand architecturally what's going on under the hood, but they're basically treated as implementation details to the integrator. Cool. So let's talk about standard relaying for a little bit here. So this is just one relaying methodology on Wormhole, but it's meant to be very composable. So it's sort of, when you look at like the hello Wormhole example, which we'll be going over a couple of lines of code from that in a few minutes here. This is just sort of like the drop-in module that gets you relaying right out of the box in like 5 minutes. And it's designed for like the majority of use cases. The majority of use cases in Web3 right now are like, you send a message, you want to make sure it gets, when you request it, you may want to make sure it gets there exactly once. That is, 90% of the use cases. There's also sort of important considerations around like round tripping. Like a lot of times you'll want to go from like A to B and then B back to A. So like all of these use cases are well supported in standard relaying. And the key piece here is that there's zero infrastructure. You deploy smart contracts, that's it. You just like deploy your smart contract, go interact with the Wormhole relayer contract, and the Wormhole relayer contract is going to set up the incentives, call the core contract, all of those sort of things, without you having to manage any infrastructure off chain. It's also composable with other modules in the ecosystem. So like with SR, you can not only like just sort of like send a hello world message or whatever, but you could also like call the portal contracts and, send some wrapped ETH along with your SR payload. You can also compose it with Circle's CCTP. So you can send USDC along with your SR message. And it supports other protocols built on Wormhole because it actually just like brings along arbitrary VAAs. So long as you can separate out the VAA, you can send it on SR. Currently, it's on, I believe, all of the EVM blockchains. So every EVM blockchain that's supported in Wormhole has SR available, I believe. So sort of like key features, we went over this a little bit. already, but I'll just like quickly go over these again. So it's pay up front. So you basically like call into a delivery provider. The delivery provider will say, oh, you're trying to do this? Here you go, pay this much. And then it happens. So you just get one quote up front. To the end user, it just looks like a bigger transaction fee. And there you go. Like it's kind of just like fire and forget from that perspective. And it's designed for both these like hub and spoke and mesh design. So hub and spoke is one where you sort of have like one main contract and a bunch of satellites. And in that one, you often are going from like A to B back to A. And then mesh designs are more like a peer network where you just have like an identical smart contract deployed to a bunch of chains. Both of those are well supported. And the idea here is like make the basics really simple, like sending a hello world message. You'll see like you're going to get it. But it's also very extensible. It has like some advanced features. There's a lot of consideration built into like the refunds, how to do round tripping, how to, send additional messages along and all those sort of things. So, yeah. And also it's extensible to heterogeneous ecosystems. There's a few considerations built in there that make it extensible into like, Solana and Aptos and Sui and all those sort of things as well, though it is currently only on EVM. So yeah, here is how you send a cross-chain message. So you see it's just a single invocation as far as this goes, right? So we're gonna just send a hello world message. You can imagine that greeting probably says hello world. And there's really only two things happening here. You call in to a quoter, which we'll see on the next slide. And then you, off the Wormhole relayer, which is the standard relayer contract in this case, you call send payload to EVM, which is one of the convenience overloads. We'll also look at the sort of full signature so you can see what the full feature set is here. But yeah, effectively, you're kind of saying the things you expect to say, right? So it's like, hey, I'm going to send, I'm going to send my little hello world message here. I'm going to pay for it, and I'm going to send it to this contract on this address. I'm also going to specify a gas limit. So there's also a capacity to add receiver value, which just comes in as message value on the target chain. So that's not like it's not just like a dead feature you can't use, because it ends up being a very important quality of life feature. But yeah, I mean, like there's only a few arguments. They're mostly what you think they'd be. And in terms of quoting, the quoting is kind of interesting because you need to create an abstraction, because the fee modeling works differently across like so many blockchains. Like even the L2s versus the L1s are like notably different to the point that you kind of need to model them differently. And then once you get into Solana, into Sui, into whatever, you really just need like an abstraction. So in this case, we just sort of have like the basic quote for like, I'm just going to an EVM. Like I just need some gas limit. Just please execute this with like 500,000 gas or whatever. And that gets it done. But there's also some considerations to make that forward extensible. And yeah, on the other side, like once you've sent the message, this is what gets invoked. So you as the integrator are responsible for implementing receive wormhole messages, which is the function that the wormhole relayer contract is going to invoke when it delivers, when it performs the delivery. And once again, this kind of has the things you expect to see on it. So just going one by one in the arguments here on receive wormhole messages, we have the payload. That's obviously your arbitrary byte array. But then you also have additional VAAs or additional messages, which can be any VAA. You can effectively just say like, okay, well, I want to send this, but also I initiated a token transfer. I'd like you to deliver that as well. So that's a very important part for composability. Then we have the address. We have this third one, which is the sending address. So this is just literally the contract which sent the message. And then you have the source chain that originated from, and a bytes32 hash as a unique identifier in case you want to do some like custom replay protection or something based off that. That's kind of it. The only thing that we do here is basically verify that it can't be called by outside callers, because that would bypass some of the security checks with which the Wormhole relayer contract does. And then, yeah, do whatever you want with it, right? So in this case, we just sort of like parse it, shove it in memory, and emit event and emit an event. There's also refunds. So you're going to pay a quote. So like, the quote will be, it's always quoted in native currency. But then you also get a refund. So if you kind of want to like shoot high and be safe and make sure that you're not going to run out of gas, you can do that without there being particularly much penalty, because anything that's unused is going to be sent to a refund address of your choice, which we'll get into that now talking about send. So this is the full actual interface that kind of like talks about all of the things you can do. So this is sort of like the messiest, most fully featured implementation. And the notable things here are just that you have the refund chain, the refund address as well. And the reason that you can do a refund chain and a refund address is because cross-chain refunds are actually supported. So you can say like, well, go do it here, but then if there's a bunch of money left over or whatever, like initiate a new send to send it back to the original chain or something. And that can be really useful when you're like relaying into a really expensive chain or something of the sort. It also supports instant messages. So you can set the consistency level here to instant, and the delivery will happen like hot off the wire, basically. So it won't like wait 15 minutes or 18 minutes or whatever ETH finality is. It'll just like, go straight hot off the wire. And this means that the delivery providers are taking a risk, right? Because if the source chain transaction rolls back, you've already prepaid. But then, it's sort of like a zero, the delivery provider effectively performs that relay for free. So that is a consideration in the coding as well. All right, we are coming up on a little bit here. Okay, so next thing is, I think, going beyond SR. So SR is good for this sort of like A to B EVM use cases, zero infrastructure. You can get it working in less than an hour. But specialized relayers are also a huge consideration here. And they're always going to be, because there's always going to be use cases where people will want to go down to the lowest level, sort of like optimize for their exact use case, design exact, just keep costs down, all those sort of things. Like there's just with the ability to sort of like home roll your own relaying really unlocks a huge amount of opportunities at the application level. So right now it's required to basically do this on Solana and Aptos and Sui and others, partially because those ecosystems are a bit more complicated to interact with than EVM. So for those of you who've worked with Solana, you know that you have to include all the accounts in every transaction, and that's very difficult to it's very difficult to figure out what the accounts are unless you have the ability to like custom write the client side code. Similarly, Aptos has like considerations around that you can't. The way that like object acquisition works is kind of non-trivial, and there's some things like you can't deliver tokens to an address unless they've pre-approved it. So there's like some considerations in both of these ecosystems, and then like 5 others beyond that too. So protocol-specific optimizations is also huge. I think that one's fairly obvious. But there's a lot of different ways you can sort of like design a relay solution. So like similarly to how I was saying, like Pyth just doesn't relay most of the stuff unless like there's a demand for it. So it's sort of like a demand-based relaying solution where I don't know what percent gets relayed, but it's not 100. You could also just sort of like do bounties where you just sort of say like, well, if you relay it, you get this little reward here. And if the reward isn't sufficiently high, it just won't get relayed. But that might be perfectly good for your use case. You can also do off-chain quoting with like signed quotes and things like that. There's really quite a few ways you can design these and just make the sort of game theory of it work out. And this is a key differentiator to a lot of previous models. So like in IBC, for example, you don't get this luxury. In a lot of other interoperability protocols, you can't decouple the relaying from the attestations because it's like key to the security model. So this is kind of a big differentiator that we've worked hard to sort of maintain. Okie doke. So I think the last thing here is that I've talked sort of at length here about just sort of like, what does it take to just like do a thing over here and get like some arbitrary byte array over here on the other side, which is message passing. Like that is sort of the definition of message passing. But interoperability, like importantly, isn't just message passing. You need to pass messages, but you also need to sort of accomplish a bunch of other things as well, right? So the first one is probably this like abstraction of the blockchain, or at least like creating good abstractions. So, you know, there's a few of these that just are sort of like compatibility things, you know, such as like Wormhole assigning, like having just a compatibility address format that works for every blockchain we've added so far, and hopefully every blockchain they make in the future. You know, no guarantees. Someone will always figure out a way to break. Someone will always make a dumber blockchain, right? But a big part of like what Portal does is create a compatibility standard for tokens, right? So like the ERC20 standard is not the same as SPL. It's not the same as like Cosmos tokens. It's not the same as like the Aptos token standard. So sort of like coming up with a shim that makes it an abstract representation that can be converted into all of these different token standards is non-trivial. Like that's a problem you have to go out there and solve. The trust dependencies are also important and modular. Like maintaining those modular is difficult, and that's part of why the core contract is designed the way that it is. You can verify other people's messages. Like if someone emits them, there's no reason you can't pick up that VAA and verify it. So you could totally, if it's part of your protocol and important to your protocol, send your own message, but then sort of like, you know, send a PITH price along with it and go pick up a PITH VAA and verify like, okay, you know, I should do this if the PITH price drops below, the PITH price of this token drops below a certain amount. You can just go verify that yourself. You can include both those VAAs and get it all done yourself, which is part of this key like multi-protocol composability. And it's not even just limited to Wormhole. Like as I said, SR in the additional messages field, you can just like shove CCTP messages in there. It works fine. So yeah, sort of this like independent trust modeling of like, okay, well, I'm going to trust CCTP for USDC things. I'm going to trust PITH for price things. I'm going to trust my own messages for what actions I should take. That sort of fine-grained trust model is really key to the composability aspect as well and keeping it safe. All right, so last one is just sort of like to do the smorgasbord of other features going on as well, because we've sort of just like focused on SR, kind of like what the basics are of relaying, but sort of all of these other things all factor in here too of things you can get done in the ecosystem. So the portal contracts are out there. We now also have NTT. NTT is very good for like token launches, where Portal is better suited for sort of like decentralized assets. ETHBridge is another protocol built on top of Wormhole that does L2 bridging. So like keeping the ETH representations fungible. There's also already a governance standard in Wormhole. There'll be some major improvements coming to that really soon. Wormhole is composable with CCTP. We also have CCQ and quite a few some other Oracle methodologies. We mentioned composing with PITH. There's a lot of stuff been done with NFTs. I think we built like we definitely built the first NFT bridge between Solana and Ethereum, and there've been some cool like migrations and stuff that have happened with NFTs. And sort of like all of these things are kicking around in the ecosystem and have modules and have like stuff you can take out of the box to get it done. So just a few other things to be aware of beyond the simple sort of like, you know, send hello world message. The real unlocks come when you start stacking these modules to get novel use cases done. All right. I think that is the end of my pitch deck. So I think we hand the mic over to our host here, and
Yeah. Cool. Thank you very much, Ace, for the wonderful presentation. And you know the drill, everybody. Do you have any questions? Now is the time to ask them. Feel free to pop them in the chat. Feel free to pop them in the questions tab. And Chase will get to them as soon as possible. Cool. Let's give everybody a little bit of time to pop some questions. Until then, Chase, where can people reach your socials? Are you reachable on Twitter? Are you reachable on Discord? How can people get in touch with you if they have any further questions about all of this?
Yeah, certainly. If you guys are interested in getting started developing on Wormhole, I always recommend the Wormhole Discord. There's a ton of people who just hang out there all day. There's a ton of a ton of help going on, a ton of support, a ton of just questions and answers happening all the time. So I think that's definitely the best place to get started.
Cool. Amazing. Any questions, anybody? Let's give it a minute more to see if anybody needs anything. Until then, why don't you tell us a little bit about this QR code you have, and I assume it leads to a GitHub repo, which you link as well, right?
Yeah, so Wormhole is fully open source, and the best place to go dive into it, if you want to really dive into the code examples, is definitely at the Wormhole Foundation GitHub repository. So the code examples that I showed were from our Hello World example. There's some more involved examples that do CCTP transfers, do token transfers, as well as the official SDKs, all of that sort of stuff is available there. Relayer engine will help you get started if you're doing some specialized relaying. It's all kicking around. The mono repo is a little the main repo of like the Wormhole mono repo is a little intense. If you get digging in there, like there's it's got a lot of code, but also the Hello World and like the SDK repos are much more approachable.
Yeah, cool. We have a question in the chat. I don't know if you can see it. Sam is asking, can I work with this technology on popular testnets?
Yep. So all the testnets you would expect to be supported are supported. And if you go to docs.wormhole.com, there's a huge table there, all the contract addresses, all of everything. It all works in testnet like you think it does.
Cool. Somebody else is typing. Cool. Yeah, it doesn't look like we have any more questions, but that's fine. Oh, actually, there's a question now. What are some things that the Wormhole team would like to see built?
Yeah, that's a great question. I am always super excited when I see people either utilizing like a heterogeneous blockchain in some like really cool way. Like a good use case for Wormhole is just sort of like go from expensive places over to cheap places and then like get a lot done, like start off in like ETH, which is, the most expensive thing on earth, and go over to Solana where compute is basically free. And then you can kind of like come back and things like that, or just leveraging protocols that don't exist on other chains, right? So you might be like, oh, there's this really good borrow lend thing over here and this like, but tons of liquidity over here or something, and just sort of like stringing together multiple protocols, I think is also a super powerful use case. So anytime I see something like that, that's what I get most excited about.
Yeah, definitely. I think that's good. A very good answer as well. Cool. I don't think we have any more questions, which is fine because we are nearing our deadline anyway. So Chase, any final words of wisdom for the guests?
No, I don't think so. Thank you guys so much for having me. This has been a fun chat.
Yeah, it has. Thank you for coming in, for holding the session, and thanks to everybody else for coming and listening. Then see ya on Wednesday for session number 4, and until then, have a nice evening or day, and yeah, See you around. Bye-bye.
Thanks, everybody.